Designing and creating tables. All right, so as we get deeper into the database world here, we're going to begin targeting specific database objects. The first database object we're going to talk about here is probably one of the more important, if not the most important database object, and that's the table. The table is important because this is where all the data is stored inside of our database. And of course, we're not just going to have one big table. We're going to have many, many interrelated tables that all work together to store this data. But really, what I want to get you to start to begin thinking about here is table design, because it's easy to create a table. That's the easy stuff. And I'm going to get you familiar with all things, all the different ways that we can create a table, everything that goes into a table, things like that. But the important thing is that we design our tables with data integrity in mind and also efficiency in mind. And the reason that's important, because if you have a sloppy table design, well then of course the data that goes into that table is also going to be sloppy. So we're going to cover all that stuff. The first thing I'm going to get you familiar with though is just all the things that make up a table. So I'll get you familiar with some table basics here, an introduction to tables. What is a table? How does data look when it's in a table? What are rows, columns, that sort of thing? Just kind of take a brief overview of a table. We'll then also move into data types, of course, a big part of tables. We'll take a look at what data types are and give some examples here of some different data types. And then, of course, the big one here, data integrity. We'll take a look at all the different forms of data integrity, from constraints to defaults to rules, so on and so forth. So the first part here is just introducing you to everything tables. We'll then get into the nitty-gritty here, and I'll get you familiar with creating data types and tables. And also in here, we'll take a look at some basic design concepts, because again, it is important to design your tables ahead of time before creating them. And then we'll get into data integrity and utilizing all the different forms of data integrity, all the different forms of constraints, rules, defaults, so on and so forth. And at the end here, I'll get you familiar with using special tables. And what I mean by that is there are a couple different types of special tables, such as temporary tables, and I'll take a look at how to deal with system tables, because they're a lot different than they were in the past with SQL Server 2000 and previous. So let's begin here with an introduction to tables, data types, and data integrity. I want to begin with some table basics, just to get you familiar with what a table is, why we need tables, how we design tables, so on and so forth. Now, of course, we need tables to put data in, that's obvious. And at this stage of the game, we probably already know that we already know what we're building our database for, because we probably have our database up if we're ready to create tables. And I liken designing databases and designing your table structure inside of a database a lot like putting a puzzle together. Because really what we need to do first is gather all the data requirements. Usually it's going to revolve around a product or an industry or some sort of a problem or a challenge that you have out there. And we're going to have all these data elements that we know we need to track. We just don't yet know where they're going to go in what table and so on and so forth. So when you're drawing out your database, it's good to draw it out on paper, all your different tables, get all your data elements out there. And really, a specific table is going to represent a specific object. To give you some examples, let's say we were in the automobile industry and we wanted to design a database or create a database with a bunch of tables in it that would track all of our automobiles. Well, most likely we're going to have an automobiles table. And then off of that, we're going to have a parts table somewhere so we can track which automobiles or which parts belong to which automobiles. Another example, let's say we wanted to create an in-house application that tracked all of our computers on our network. We'd probably have a PC table or a computer table, and then we'd probably have a networks table, and we'd link those two together so we could tell which computers belong to which networks. So usually when we're designing our tables, they represent an object. They represent something. So let's take this a step further here. Let's say that I wanted to create a table that would track employees. Or let's say we have a database, an in-house database that tracks everything inside of our company, from computers to networks to departments, all the way down to the employee level and which employees belong to which computers, belong to which departments, so on and so forth. Well, here I could have an employees table. And if you're familiar with spreadsheets at all, then you're going to be familiar with tables, because that's pretty much how a table looks. We have rows going across and we have columns going down. Columns represent attributes of that object here. So, for instance, we have a first name, which would, of course, describe the first name of our employee, the last name, and the hire date. Also, you're going to see these ID columns. Now, we're going to get into this a little bit more deeper into the video, but I just want to mention that we need a way to uniquely identify each row within a table, right? Because what if we have four Joe Smiths here inside of our table? How do we know and differentiate each Joe Smith from one another, especially if they were hired on the same day? We'd have no way to tell which Joe Smith was which Joe Smith. So we need a unique way of identifying each Joe Smith. So again, we'll get more on that when we talk about primary keys, so on and so forth inside of our constraints area. But basically, that's just a way to uniquely identify a row. And really, to get back on the columns here, columns are just simply attributes of an object, right? And another thing is columns have data types attached to them. So a first name, for instance, would be a character data type, right? First names aren't going to be of numbers or symbols, although we have seen that in today's day and age. So they could be numbers and symbols, but usually we're going to have character data inside of here. An ID field, on the other hand, is going to be a numeric data type. A higher date is going to be a date-time data type. So columns are attributes of an object, and these attributes have data types that determine what type of data can fit in the column. Rows, on the other hand, are instances of that object. So a row makes up an entire employee. So we know that Joe Smith was hired on this specific date. So that's what a table is, and we're going to really get into tables here. We're going to build a bunch of tables, relate them all together, and see how this table stuff works. We also have data types, and a data type, as I mentioned before here, can be, we need to assign a data type to a column, but data types are more than that. And I say that because you can see here I say objects containing data need an associated data type. So not just columns, but that obviously is the most common one out there is when we create these tables, we need to create columns, and we need to assign data types to columns to determine what data fits in them. But it can be more than that. When we get into stored procedures and creating variables and such, variables need a data type. Functions can return data types. We have a video on functions. Also parameters. Parameters that come inside of stored procedures also need data types so they know what data can fit in them. And ultimately, we end up using those parameters to put data into table or other things. So that's all a data type is. There's many different types of data types out there. Character, as I mentioned, numeric, as I mentioned. We have date time, as I also mentioned. We have money, Boolean, which is just a true-false value. Binary data types for storing images and things of that nature, any type of binary data. And even a brand new XML data type where we can store entire XML data elements inside of a column. We can also make our own data types based on one of these what are called native data types. Which are native just meaning native to the SQL Server language. So we can build our own data types, streamline, make our own data types based on other data types. And we'll get in here to creating our own data types when we get into a demo, and we'll also use a bunch of these built-in data types when we create columns within our tables. Now, we also have data integrity, and again, data integrity very important because we're going to use all these different forms of constraints, defaults, and rules to pretty much control how the data is entered and also how it looks when it gets into our table. Starting from the top here, we have null constraints, and null, very popular. It's basically we're just when we create a column in a table, we're gonna set its nullability. Can this column accept null values or not? It's as simple as that. Yes or no. If we're going to say yes, it can accept null values, then that means we can put null values into a column. And what is a null value? A null value is nothing. It means no data at all. So not empty data, just absolutely nothing. And null does not equal null. So null is just that. It's nothing. For instance, let's say that we didn't know Joe Smith's hire date. Well, we wouldn't want to put anything in here. You know, we wouldn't want to put 1100 or 1901. We wouldn't want to put nothing in there. So that's where a null value would come into play, and we'd probably put this hire date column as a nullable column. We also have check constraints, and check constraints are kind of like checkpoints. Before that data gets into our table, we can have a check constraint on a column to say, you know what, make sure that this data is between these dates, or make sure that this date coming in here is greater than 1900, so on and so forth. So a check constraint is just kind of like a little filter that we put on, a checkpoint, excuse me, not a filter, that we put on that would say, does this data meet this criteria? Does it fall in between this criteria? If so, put it in the table, let this record get entered into the table. If not, we're going to kick back an error saying, you know, check constraint was violated. You can't put the data into this table until it matches this checkpoint. We also have unique constraints, and unique constraints are great for if we want to have a unique column. And I'm not talking about the column we were talking about earlier. That's actually going to be a primary key column, and I'll talk about that briefly here shortly. But a unique constraint is great for anything that isn't a primary key column that we want to make and allow to be unique. So we can create a unique constraint on one column or multiple columns, what is called a composite unique constraint, because it spans multiple columns. And again, we'll talk about that as well when we get into it. Primary key, again, that's what I was talking about earlier, where we need a unique way to identify our row. You can only have one primary key on your table, and a primary key can also span multiple columns, but we're going to designate a column or columns as a primary key, again, to uniquely identify the table. And a primary key column or columns cannot have null values. So one thing to take note of. Again, we'll work with primary keys when we create our tables. We also have foreign keys. Foreign keys are primary keys in other tables, and what we're going to really do here, primary keys are used on joins. Again, when we have multiple tables out there, when we write our queries, we need a way to grab data from both tables. We're going to have to join them together so we can get that related data. And what we're going to do is we're going to hook up our primary keys to our foreign keys, or vice versa, within our joins to grab that data and link those tables together. So again, we'll talk about this as well when we get into creating a database diagram and linking our tables together through these common columns. Now, we also have defaults, and defaults are pretty cool and very easy to use. A default allows us to specify on a column a default value, and then if a user doesn't enter a value for that column, the default will automatically get entered for it. So, very simple way to control what data goes into a table rather than a null value. We can control that. So, defaults, good stuff. We also have rules, and rules are, as Microsoft says, are going to be unsupported in the future simply because they're pretty much check constraints. They're pretty much work the exact same way, other than rules are actual objects that we bind using a stored procedure to a column, where a check constraint is just a property, and the cool thing is we can have multiple check constraints on a column where you can only have one rule. So rules are kind of becoming outdated, and Microsoft will eventually drop support for rules because check constraints are more flexible. But we'll talk about both. I'll show you how to use both within our tables. All right, the next thing we're going to do here is head right into SQL Server Management Studio. I'm going to show you how to create all of these objects inside of the database. So to get there, let's head on down to that Start button, up to Programs, over to SQL Server 2005, and right down to our SQL Server Management Studio here. As soon as this fires up, I'm going to connect right into our SQL 2005 production instance over on our SQL Nugget database server, and this will give us a connection to that server right in Object Explorer here. Now, again, before you get into this stage and go ahead and create the physical tables, we're going to have whatever situation we're trying to solve here, whatever solution we're trying to model, we're going to have it mapped out ahead of time on paper. And what I mean by paper is, yeah, you could use pen and paper to do it, simple, easy way to do things, but I personally like to use Microsoft Visio. It's a wonderful modeling software solution for database modeling, and it goes well beyond just modeling databases. You can model pretty much anything you can think of, including software. So that's why I use it, because you can model software components as well as database components. And again, though, before we come in here and we create these physical tables, it's a good idea to have whatever problem you're trying to solve mapped out. So in this instance, what we're going to do is come in here, and I have 3 tables that we're going to create, and we're going to, of course, create the relationships between them, and then we're going to create a database diagram just to get that out inside of here. It's kind of, a database diagram is great just to see, again, a big visual on how your tables look and how they link together, and it's also a little piece of documentation on how your database looks from a bird's eye perspective. All right, so let's create some tables here. What we're going to do is we're going to take the CBT Nuggets business model, and we're going to attempt to greatly simplify it and turn it into a database here. So we have the CBT Nuggets database that we've been working with for the past few videos, and we're going to create 3 tables. We're going to create a trainers table to hold all of our trainer information. We're going to create a videos table to hold all the different videos, and then we're going to create a series table. Now, all 3 of those tables themselves are distinctly separate entities within the CBT Nuggets business model, but they all work together to form that model. Of course, if they were all just single by themselves and they didn't link to anything, they'd be kind of worthless. Take the videos table, for instance. How would you know which series those videos went to if they were just a listing of all the videos in the CBT Nuggets inventory, right? It'd help to know what series they belong to. So we're going to create these tables, and the first table we're going to create is the trainers table. Now, to create a table, simply right-click on the table node here and choose New Table. What this will do is it'll create us a new tab up here, which will allow us, of course, to create a table. And inside of a table, we're going to specify our column names, our data types, if we allow null values, and then we're going to have all kinds of other different properties on that column we can set. So once we get all of our columns in here, I'll show you, we'll save the table, and then we'll create our other 2 tables, and we'll be off and running with the CBT Nuggets database model. So the first column we're going to create here is going to be our primary key column, our identification column. So it's going to be the trainer ID. And really, when you're looking at a column, you're looking at all the columns in this table that you're going to create. You need to have a column that can, again, uniquely identify each row in the table. Now, say that you have an employee table and you have a social security number in there. That is a perfectly good example of a column that you already have data in that table that you can use as a primary key identifier. But in our case, let's say we're just tracking first name, last name, and hire date. You don't really have, a column that we can use that's always going to be unique, right? So we need to make our own identification column. That's what we're doing here. We're going to have a trainer ID column. The data type we're going to use for this is going to be a small integer. And if you're not sure what these data types, the values that they could range from, like I know small int, for instance, can be a value from negative 32,000 to positive 32,000. I know that we're probably not going to have any more than 32,000 trainers, so this will be a perfect example of a good data type for this column. And we could actually probably even get away with using a tiny int. And a tiny int is a value between 0 and 255. The problem there is if we ever get more than 255 trainers, well, we're going to have a design issue, in which case it wouldn't be too big of a design issue. We could just change the value, change the data type on this column, upgrade it to a small int. But a really good thing here, if you're not sure what some of these data types are or what their ranges are, really cool. This is a really nice feature in 2005. If you come down here into the Programmability tab, and you head on down to Types, and you head on down to System Data Types, we have all these data types categorized appropriately for us. You can see we have exact numbers here. And if we expand this, look at this. If you hold your mouse over the data type, there you go. A bit integer with either 1 or 0, true, false. Tiny int, 0 through 255. Small int, negative 32,000 to positive 32,000. Standard int, negative 2 billion to positive 2 billion. And a big int, which is just a really, really large range of numbers. So really, really cool here that you can just come down here, take a look at all of your system data types, hold your mouse over it, and get a brief explanation of what that data type is. Very, very handy feature inside of SQL Server 2005. And finally here, the last property we can set here is if we want to allow null values or not. And we're going to bypass this just to show you. Once you make this your primary key field, if we just click right here, set primary key, it's automatically, you can't, you see if I try to check it, nulls cannot be set in, of course, a primary key field. Just, of course, we can't. It's got to have a value because we're uniquely identifying a row. Now, the next thing we're going to do is we don't want to manage this this number ourselves. Again, it's going to be what's called an auto number column, which means that every time a record is inserted into here, it's going to be managed for us by the system. So it's going to start at number 0, or excuse me, number 1, and just work its way on up all the way to 32,000 some. So we can have up to 32,000 trainers. Actually, I'm sorry, 255 because we specified a tiny int, not a small int. So up to 255 here. And if you want to auto number, what you have to do is come down here into the column properties, head on down to identity specification. We're going to change this to yes. Boom. Now what we're saying is increment it by 1 every time and start at the number 1. So your seed is where it's starting to count from. Your increment is what it's incrementing by every time a record gets put into here. So there we go. Now we have our uniquely identified column up and running. And now we have a unique identifier and a primary key in our table. And now we can start working with the actual data columns themselves. So the first data column we're going to trap for here is first name. We need to know the names of our trainers. The data type on first name, we could do a few things here. We could have, you can see we have these varchars here. Varchar with a specific number of characters, or varchar max, meaning the most storage a varchar could actually take up here. You also have end varchar, and same things here. We can actually specify the amount, the maximum length for this field, or we could just say max. And there's also just regular old car. So the difference here is, of course, the ends are Unicode data, and they double the storage of their counterpart here, the regular old cars and varchars. The difference between the varchar and the regular car, as you'll see up here, the difference between these is the var stands for varying character data. And what that just basically means is SQL Server is going to store only the number of characters that the name takes up. So say we're gonna make this for 100 length here, and say we enter a row where the first name is only 10 characters long. Well, SQL Server will actually trim that 90 extra spaces of storage out of the data file and then just store the actual name itself. Where a car field all by itself, you can see down here an end car here, it will actually store all 100. If we were to choose an end car and specify a length of 100, it would always store it as 100. So the difference, of course, the car is a little better in performance because SQL Server doesn't have all that trimming and move the space around and all that stuff to store the data. But yeah, it's probably negligible because our database servers these days are huge. So we got our first name in there. We're going to uncheck the allow nulls here because who doesn't have a first name these days, right? And then we'll have last name here. We'll do the same thing. Let's make this an end varying character here with 100 length, and same here. We'll clear the allow null, so we're not allowing for null values. Let's get a few more columns in here. How about hire date? Higher date is going to have, of course, a date time variable. Now, data type. We can use date time or we could use small date time because we don't really care about the time they were hired. If you do, we could use regular date time, but we only care about the date in this instance, so we'll say small date time. And let's say we have trainers in the past in this database we're implementing now. We don't really know their hire date for whatever reason. We'll leave this null. So we can say we don't technically need to know their hire date, so we'll leave that null. Let's add one more in here. How about an active flag to say if the trainer is currently working on a series or not? And this is going to be a bit field. One of those fields, as I showed you down in the programmability area, is either going to be a 0 or a 1 for true or false. So we're going to actually, on this one, we're going to clear the allow nulls flag here as well. Now, a couple more little things before we save this table. Down in the properties down here, you can see we have pretty much all the information we specified up here, the name, the data type, whether we're going to allow nulls or not. You can also do other things in here, such as specify a default value. And what we can say here is if they don't enter a value, what's it going to be? So let's put a default on our active flag column as 0. And let's put a default on our hire date column as, how about today's date? And we're going to use what's called the getDate function here. And you can actually use SQL functions right inside of here. You can put code right in here, and it'll actually run the code anytime a record is inserted and a value is not supplied. It'll use the default. So in this instance, if we enter a record and we don't supply a hire date, it'll automatically assume today's date. Pretty cool, and save some of our work there. You can also put a description on your columns right here, good for documentation purposes, so you know what you were thinking at the time, and if anyone else comes and works with our table, they'll know what we were thinking at the time when we designed this table. And that's pretty much it for the general properties of our column. So we have our first table built, pretty simple. Let's go ahead and save it. And we can do that here by clicking on the Save button, entering a name for our table. Let's go ahead and call this Trainers, and clicking OK. And that should add the table to our database here. There we are. Now we can see just some basic information about our table by just simply expanding it here. You can see all of your columns listed down here. Again, base information, their data type, the length of the data type, the nullability of the column. You can see this is our primary key up here. You can also see your keys by expanding the keys table. This will also show foreign keys, which we'll touch on here in a minute. And then you can also see your constraints here. You can see we have two defaults, our default underscore trainers underscore active flag. So just system generated names on these constraints. I'll show you how you can actually make your own default object as well and give it your own name. But again, just basic information about our table here underneath the table. Good, easy way of viewing all that. Now, what we're going to do here is I'm going to open up a script and we're going to make our other two tables in code. And I'll also show you how this table looks in Transact SQL. So let me go ahead and close out of our table here. I'm going to go to File, Open File, and I have our tables, data types, constraints query here. And I'm just going to hook this right up to our production database and change our connection right into our CBT Nuggets database. And there we are. So this is how the trainers table looks in code. You can see we have our trainer ID column. It's a tiny int. We specified we want this to be an identity column with a seed of 1, incrementing it by 1, and then it's not null as well. And then we have our first name column with its data type, last name with its data type, hire date with its data type, and also we have a constraint on here. And this is how constraints work. When you want to add them, you do a constraint followed by the name of the constraint, followed by the type of constraint. This is a default, and then the value for that constraint. And this one, of course, is going to be getDate, so that whenever, again, a record is entered in here without a value, it'll automatically assume the current date. We also have the active flag column here. It's a bit column, either a 0 or a 1, true or false, yes or no, type of thing. We have a constraint we have on here as well. Gave it the name df underscore trainers underscore active flag. It's a default, and we supply the value 1 if no value is supplied for this column. And then finally here, our big constraint is the primary key constraint. Works the same way. The only difference here is it says primary key clustered. And we'll cover what a clustered index is here. That's all this really is a clustered index noted as a primary key. When we talk about indexes in the next video, we'll talk about what a clustered index is. But basically here, primary key on the trainer ID column, built on all of this built on the primary file group. The next table we're going to put together here is the videos table. And this table is going to store all the videos throughout all of CBT Nuggets, no matter the trainer or the series. The idea here is it's just going to be pretty much a repository for all of our videos. And we're going to start off here with a video ID. This is going to be, again, our primary key, our unique identifier for each row in this table. It's going to be an integer, which means we'll be able to store up to 2 billion videos, so many, many, many videos for many years to come. And then this is also an auto-numbering field, so we have the identity turned on here with the seed of 1. We're starting at 1 and incrementing as well by 1 every time a new record is put in. We have the series ID, and this is actually a very interesting column because this actually brings up a design issue. And what this is here is technically it's called a foreign key, and a foreign key really is a primary key in another table. So if you see down here in our series table, we have a series ID as the primary key. This column is going to link into our videos table so we know which videos belong to which series. So this is called a foreign key again because it is a primary key in another table, and that's where our link is going to be. And we'll get into this relationship stuff here when we actually create a database diagram and again get a visual perspective on how this stuff works. But I mentioned this brings up a design issue, and this is kind of cool how this works. Now, we could leave this as not null. Not null means, of course, that anytime we put a video into this table, that there has to be a series assigned to it. So what does that mean to our trainers who are currently developing videos and maybe they don't know the series name yet? So we haven't created the series in here. Well, that means they couldn't put their videos in here. So really what we may want to do here is allow null values on here. And what that would mean is any video with a series ID of null would mean that it doesn't have a series attached to it. So again, this would be one of those design issues that you have to mull over with whoever the decision maker is, ultimately the decision maker on this database, whoever you're creating this database for. Do you want to allow trainers to put videos in that don't have a series or not? Or excuse me, or do you want to allow them to put videos in here without a series? So that's the question, and again, that's just a design issue that you have to mull over with the decision makers. But pretty cool. I thought I'd bring that up and kind of show how that works. And again, we'll talk about the relationships here when we get into diagramming and how that would work. We also have video name. Of course, we need to track the name of our videos here, so we have a variant character field with a 500 character length on there. We also have a length field. In the length field, we're going to use a data type of a float. A float is considered an approximation data type. It's an approximate number, not an exact number, such as an integer, a small integer, exact numbers. And a float can store a very, very large approximation number here. Numeric is our next data type, and this is, of course, going to be the size here. So the size meaning like 12.25 megabytes, so, as an example here. And this is a numeric data type. Numerics and floats are both approximate data type. A numeric data type, though, we get to set what's called the precision and the scale. The precision here, the first number, is how many decimal places are you allowing to the right and the left of your number here. And the second parameter on numeric data types here is how many of this scale, how many are going to be to the right of the decimal place. So we're saying 2 total, 2 to the right. So basically we're just saying we're going to allow 2 decimal places to the right of the number. So that's going to be our size. We also have a creation date time column. It's going to be a date time column, not a small date time column, so we can actually also track the time that this video was either uploaded or inserted into this database. And we also have these set as not null. And then finally here we have our primary key, which is of course our video ID. As I mentioned earlier, works the same way as our trainer ID above. One thing we may want to do to this table is add a default to our creation date time here. So why don't we do that? I'm just going to go ahead and copy the code up here for our default constraint. We'll bring it on down here into our date time, and we'll add our own constraint here. Why don't we call this one videos, df underscore videos underscore creation date time. So pretty much the same exact default as above, just to get date, get the current date. Whenever a video or a record is entered as a video into this table, it'll automatically assume the current date and time. So let's go ahead here and create our videos table. We'll highlight this code, click execute. Now if we go over here and refresh our table node, there we go. We now have a videos table. All right, now head on down to our series table. Our series table has a series ID. This one's going to be a small int as well. Of course, these have to match here since we're going to link them together. So we have a small int. It's also going to be an identity, an auto number column here, starting at a seed of 1, incrementing by 1. We also have a trainer ID here, and a trainer ID this is actually a foreign key because it's going to link back to our trainers table, so we know which trainers developed which series. And then we have our series name. We have a price. You can see it's a money data type. We have a creation date here. We'll call this creation date time here. And why don't we do the same thing? Let's add a default constraint to this guy. I'll just copy this code above, paste it on in here, and we'll only name this one series. Creation date time. There we go. And then we have a publish date. So the date that it was actually published, we'll leave this one to allow for the user to enter that. And then finally here we have our primary key constraint on series ID. So pretty much same basic table, just a few different columns and data types. So let's go ahead and highlight this one as well. Hit execute. Now we have a series table and we have all of our tables set up. If we refresh this over here, now we can begin creating the relationships and creating a database diagram for these tables. To do that, we need to head on over to our database diagrams node here, and as soon as you click on it, it's going to tell you that the database does not have one or more of the supported objects required to use database diagram. Basically, it's missing a system table and it dynamically creates it for us. So if we say yes here, it's just going to create that system table for us. And you can see that, if I just expand that here, it doesn't think it has any system tables. Well, if we refresh it and then expand it, check it out. It had to create this sys diagram system table for database diagramming. So now that we have that, now we can right-click on our database diagrams and choose New Database Diagram. First thing it's going to ask us to do here is what tables do we want to add to the diagram. We want to add all three of them in here. We'll go ahead and click on highlight all three, choose Add. Now we can click Close. I'm just going to go ahead and take our zoom down a little bit here so we can see all of our tables. Here we go. And here's our three tables: trainers, series, and videos. Now, to create relationships, very simple, especially if you design it correctly and you have your columns named, appropriately. We can create these relationships really easily here. We can say trainer ID to trainer ID here, and it's just going to pop this up. I'm going to leave the defaults here for the relationship name. Our primary key table is trainers. Our foreign key table is series. There's the common key there, trainer ID. You can choose OK. And then we have some basic properties here you can set on your relationships here, such as you can check existing data to make sure that we don't have any orphans. So if you're entering data in the foreign key table, it has to have an associated record in the parent table. So we choose yes there for this one. And then we also here have, just to show you some of the more common ones here, you can do insert and update specifications. This is where you do what's called cascading. Cascade updating and cascade deleting here. If you choose no action, nothing's going to happen. If you insert a row, or in this case, if we delete a row, say we delete a series, right? Do we want to automatically delete all the videos associated with that series? And that's exactly what we're saying here. Same with this one. If we delete a trainer, do we want to delete all of the series associated with that trainer? Well, we don't want that to happen. There are certain circumstances where you may want to do that, and we're going to say no here. But you can see this is pretty much your options here. You can cascade, which means cascade delete in this case. You can do set to null or set to default. And then same thing on an update. Pretty much have the same choices there. But that's pretty much it. You can add, again, change the name, add a description. If we say OK, now we have relationships set up between our tables. We also here have series ID to videos. So series to videos here, primary key table series, foreign key table videos, series ID is our common column there. So we click OK here, we'll click OK here, and boom. Now we have our relationship set up between our tables. Simple as that. You can see we kind of have a bird's eye view here on our database diagram. And you can do some pretty cool things in here. You can do things like view your page breaks, and this really turns into an excellent little documentation tool that I personally use quite often, because you can put your own text annotations in here. You can write things down. You can show relationship labels here if you like to actually see the names of your relationships. You can do quite a bit of things. You can also change the view on these tables to something such as this, standard, and then you can alter your tables right in here. You don't need to go in and modify the tables themselves. You can change column names, change data types, and you can get really fancy too and actually make a custom view where you can choose all of the properties, and you actually have to go in here and choose modify custom. All the properties that we saw earlier are pretty much in here too. So you can use this as a design tool, development tool. You can use it as a documentation tool. I personally love database diagramming because it just gives a bird's eye perspective on your database. So we'll close out of this. We'll say, yep, let's save it. We'll call this relationships. And hit OK. We'll choose yes. And there we go. Now we have a database diagram. Now another thing we can do here is create our own data types. Just like we have here, small int, tiny int, varying characters, money, daytime, we can actually create our own data types. Now we're not actually going to create our own data type from scratch, although you can do that with a .NET compliant language. So you can use Visual Studio.NET or your favorite programming language, and you can create your own data types, but that takes a little more work and is a little outside of the scope of this series. But basically how it works here, to create your own SQL data types, they're based on existing data types. So really what you're doing is you're tweaking an existing data type to match, your flavor, whatever you want to design. And then you can use that data type just as we do here, just by using its name. Now you can do this graphically through the designer, or you can do it in code here. I'll show you both. To do it graphically, you go into the programmability node here, head on down to types, and head on down to user-defined data types. And again, if you want to make your own own data types in your own language, you can use user-defined types here. And you're going to have to actually use transact SQL code to create user-defined types. But user-defined data types, we can right-click on it here, choose new user-defined data type. It's pretty simple. You just give it a name here. So we'll call this SS for social security number here. How about SS number? There we go. The data type we're going to use, how about we go ahead and use a char. We know that most social security numbers are 11 characters long here, so we'll do just that. And you can choose whether to allow nulls or not in the data types. And that's pretty much it. So really, to create a data type, very simple. Just give it a name, choose your data type, choose your own length for it and whether you want to allow nulls or not. And that's it. Now we say OK, and boom. We've got ourselves our own data type. And you can also do that here in code, as you can see. Create type, I'm calling this one SSN just to show you the difference, from varchar 11. And we're saying it's nullable. So if we hit execute here, and then refresh our user-defined data types, you can see the difference here. Here's a social security number that does not allow nulls, and here's one that does allow nulls. Just a couple of different names, one in code, one graphically. Very easy to use to create defaults, your own data types here. And then, if we wanted to use this, we can just do this, SSN. There you go. It's not going to highlight it in blue because it's not standard SQL syntax, but it will recognize that it is a data type. Now, another thing we can do here is create our own defaults. Up here what we did is we kind of created a default on the fly. You can actually create your own default objects and then use these default objects here. You can just say constraint and the name of the default, and boom, it'll attach it automatically here. But really, if you want to create your own default objects here, you just do a create default name of the default as, and then the value of the default. So here, if we wanted to create a default social security number, we could do this. Create default df_ssn as, and then here's the value here, just a zeroed out social security number. So if we hit execute, there we go. Now to see these, what we can do is head on down to the defaults node here under programmability. We'll refresh it. Check it out. Now we have a df_ssn for a default social security number. Now the next type of constraint we have to work with here are check constraints. And check constraints are great little checkpoints. Before data gets entered into a table, we can put a check constraint on a column to say, if this data that's coming into the column does not meet the criteria in our check constraint, we're going to reject the entire record from entering this table. So check constraints are just great little validation techniques that you can use to ensure the data is in the range or format that you want it to come into the table. So what we're going to do is here, we're going to add a check constraint on our trainers table on a hire date column. And basically what we're going to say here is if the hire date is before January 1st of 1996, we're going to reject that trainer record because maybe our company started up in 1996. There's no way we would hire anyone before then. So it's a perfectly a valid little check constraint here. And how this would work here is basically this is an expression, right? And if this expression, once the data comes in, the data will replace this hire date, and it'll basically just evaluate that. And if the expression evaluates to false, then obviously the check constraint was violated, and it'll, again, reject the record here. So let me show you the syntax here before we execute this. It goes alter. We're altering the table because the table already exists. Otherwise, you can use just like we did here. We just add a check constraint. But we're going to say alter the table trainers. With check means check the existing data on the creation of this check constraint, and it'll spit out any records that that do not match this check constraint. We say with check, add constraint, name of the constraint, followed by the keyword here, check, and then our expression. Of course, our expression here is the hire date must be greater than or equal to January 1st of 1996. So let's go ahead and highlight this code, hit execute, commands completed successfully, and now if we head on up to our table, our trainers table, and expand it, expand our constraints here, let's go ahead and refresh this. There we go. Now we have a check constraint in there. That's the trainer hire date. And you can also do this graphically, by the way. You can right-click in here and choose New Constraint. And I'll just show you here by looking at our constraint. If we double-click on this, it'll fire open our constraint. Here it is. Here's our expression. Here's the name. You can also give it a description here and a few other things as well. So those are check constraints. Again, very easy to use, very powerful stuff. We also have rules, and rules are becoming more and more obsolete. In fact, Microsoft did say that they're dropping support here for rules. And the reason they are is because they're kind of ancient as far as SQL Server goes, only because they're not as flexible as check constraints. Plus, what we have to do is we have to bind them to a column using a stored procedure, and then if we ever wanted to take them off, we have to use the stored procedure to unbind the rule. So where the new constraints are built right into the SQL syntax, they're a lot more flexible and easier to use. But just to show you here for completeness sake, if you want to create a rule, you do a create rule followed by the rule name as, and then we're going to say and hire date greater than or equal to 1/1 of 96. So what happens here is this variable will get replaced with, when you bind it, you have to bind it to a specific column. So this variable will end up getting replaced with the column name here. Use the sp bind rule followed by the name of the rule, and then of course the name of the column that you're binding to. And if you want to unbind it, you do an sp unbind rule followed by, again, the name of the column. So those are rules. Again, Microsoft is pretty much saying don't use them because in the future they will no longer be supported. Now let's test out everything about our tables here by entering some data into them. Let's first enter a trainer into our trainers table. I'm going to show you how to do this graphically because we've been doing a lot of SQL and we know the insert statement in and out now. So I'll try to show you all ways of doing everything here. To enter data graphically, we right-click on a table, choose Open Table, and this will kind of open up in a spreadsheet format here. We know our trainer ID column is auto-generated, so we can leave that alone. We'll enter our first name here, we'll enter our last name here, and then we know these are auto-generated from our default, so we don't even need to specify anything here. We can tab off the record, and hitting execute here will actually commit the record to the database and generate these values. So let's hit execute. There we go. We got our auto number here starting at 1. We got our hire date, and we have the active flag turned on to true. So now we have a trainer record. Now let's get a videos record in here. We'll right-click on our videos table, choose Open Table, and let's put the video we're working on here right now in. And we don't need a video ID because that's automatically generated. A series ID, remember this was our design issue earlier, and since we haven't yet entered a series record into our series table, we don't know what series it's going to belong to. So what we're going to do is leave this empty for now. Once we create a series record, we'll grab that series ID, we'll come back in and assign it to a series. So the video name, we'll add this one in here, Designing and Creating Tables. The length, how about we just call this 30 minutes long. The size, how about this is going to be 120 megabytes here, so 0.12. And remember here, if we actually tried to put in, say, 120, we're going to get yelled at here simply because, and I just tabbed over here, simply because the way we defined our numeric, remember if we scroll over here, we defined our numeric, as I scroll up, there it is, the size of the numeric is 2 as our scale, and 2 is our precision, which just basically means the total amount of decimals, total amount of size on this can be 2 lengths, but we can have 2 on our decimals. So what that means is no matter what, we're only going to have 2 characters, and it's always going to be 2 to the right of the decimal place. And that's exactly what happens here. So we have to do 0.12. But we're trying to express this in gigabytes, so that's what we wanted anyway. There we go. And then the creation date time is automatically generated for us, so we'll just tab off of this record, hit execute, so it'll commit it for us. And there we go. Now we have a video entered. And finally here, let's get a series record in here. So we'll right-click on our series table, choose Open Table. And again, series ID automatically generated. Trainer ID, we know there's only one trainer, and that's myself, and the initial ID there was 1. So just to show you what will happen here, let's enter a 2 in there. Because at this point, referential integrity should take over, and that's because we set up those relationships. So when we set up a relationship, basically what we're saying is there must be a trainer ID that matches a trainer in the trainer table, otherwise this record should get rejected. So let's give this a series name. We'll just call this, to simplify it here, Microsoft SQL Server 2005 Implementation and Maintenance. There we go. Price, we'll leave that null because we may not know the price point yet, so we'll leave that null. We define that as a nullable column. Creation date time, we will leave that null because the default will take over. And again, we don't know the publish date yet either, so we'll leave that blank as well. So if we try to tab off the record here, check it out. We're going to say the statement conflicted with the foreign key constraint series to trainers. Because in this database, in the table trainers, column trainer ID, it's basically, if you want to decrypt this message, it's saying there's no associated trainer with the ID of 2. So let's just come back in here, make this 1. Now if we tab off the record, it'll allow us to do so, which means it's successful. Now we just need to commit it to the database, boom, and now we have a series ID number 2. So now, since we have a series created, we can jump back into our videos table, and we can assign this video to a series. And again, same thing here. If we tried to assign, we can have it null because we allowed it to be null, but if we try to assign any series that doesn't exist, right, 13, it's going to yell at us. Same thing, series must exist. So that's why referential integrity setting for your relationships is important, because it'll ultimately keep our data clean. So there's our correct series ID. You can see it let us do that. And boom, we've got data in every table, and it's looking good. Now, the final things I want to show you here is working with special tables. We have a few special things that we can work with, and this is some really cool stuff, very useful, especially when writing scripts and using stored procedures. It's a very, very handy tool. The first thing we're going to look at here is temporary tables. Temporary tables, as I mentioned, great for scripts and stored procedures. It basically allows us to create a staging area, not a permanent, a permanent storage facility by you creating our own tables, putting data into it and such. But it's just a temporary area where we can put data into, do calculations against it, whatever the case may be. Great temporary solution for storing data. And the nice thing is it works just like a regular table. We create temporary tables the same as we would create a regular table. We put data into it the same. We grab data out of it the same. The only difference is the name and how it functions, how long it actually lasts for. And we have two types of temporary tables. We have local temporary tables and global temporary tables. Local temporary tables only last for the length of your session, your personal session. So for instance here, if we were to create this temporary table, put some data into it, grab data out of it, this table would stay there unless we explicitly dropped it, which you can do. You can do a drop statement on a temporary table. Or if we were to disconnect. So if we were to completely disconnect here, then it would automatically drop our temporary table too. That's a local temporary table. Again, only you can see local temporary tables. Global temporary tables work pretty much the same way. The only difference is any session can see them and use them, and also they only get dropped when the last session has disconnected from it. So if there's, no matter if there's any connection or session using this global temporary table, it will always stay there, again, unless it's explicitly dropped. And another side note here is that temporary tables are stored in the system tempdb database. So just to show you how this works here, again, we could do create the table just as we would create any other table. It's just that the single pound sign denotes that this is a local temporary table, where a double pound sign means global temporary table. So let's highlight all this code here. This will create a table, put all 12 months in the year into it, and then grab that data out of it. And boom, there we go. And just to show you here, if we go ahead and execute this statement again, since we haven't disconnected from our session, it should still be there. And sure enough, there it is, it's still there. So if we were to disconnect, however, which we'll do now, and then reconnect, there we go, switch our database back to the CBT nuggets. Now let's execute this statement. Look, check it out, invalid object name, 10 months. So there we go, we just proved everything about temporary tables and how they work. Global temporary tables, same thing here. We're going to create this one, put all the number, all the days, and their ordinal here with it as well. Create this table, hit execute. There we go. Now, if we were to do the same thing, if we highlight it here, although we can't really, we're not really proving anything because we don't have multiple connections to it since there's only one of me. But same thing will happen here. If we disconnect, reconnect, change our database here back to CBT nuggets and try to execute this statement, invalid object name, because we were the last connection attempting to use it. So temporary tables, very, very useful, especially when you begin getting into stored procedures and you're going to be doing heavy calculations and data manipulation and things like that. Then it's an excellent temporary storage facility to do that against. Now the final thing I want to show you here is working with system tables. And system tables are accessing them is a lot different in the past. In prior versions of SQL Server, everything was wide open. Especially if you had administrative privileges, you could pretty much access, open up, and edit any system table in any database. And Microsoft now sees that as quite a risk, not only a security risk, but a risk to your entire installation, because if you just happen to edit the wrong value in the wrong column, you could do some serious damage to your installation. So Microsoft decided in this version to lock everything down very, very tightly. In fact, we can't even see most of the system tables, let alone edit them. And let me show you here, if we expand system tables in our database, we can see the sysdiagrams table because this table was just automatically created when we created our relationship. But say we wanted to look at this data. If we right-click on it, look at this. Open table. Nope, you can't even look at the data, let alone edit it. So, rightfully so, again, they locked it down very, very tight. We can still read this data, and it is good to read the data, and I can think of many reasons. Me personally, I've built in many SQL Server maintenance apps in the past. Specifically, I've built in a database comparing system, so I could compare database objects from two databases, just, versioning issues. So it is useful to look at this data at times, but maybe not edit it. That is kind of dangerous. Do that through the interface because we know it's safe. But we can read this data now through what are called system views. So if we come down into any database and you expand your views and look at system views, tons of views in here. All of these views are plenty sufficient to look at pretty much any system data inside of SQL Server. So, and just to show you here, if we do a select star from sys.all_objects and hit execute, boom, look at this. This is all the system data relating to all the objects currently in our database. So, again, we can view the data. We just have to view them through views because they're a lot safer. Especially these are read-only views, so we can't update these views even if we wanted to. And again, here's one here for the sys databases. This will actually run through and give us a listing of all the databases. There's the master, the model, MSDB. There's our CBT Nuggets database down here, and all the system data associated with this database. Now, the last thing that I want to mention here is they didn't lock us out entirely. There is one way that you can still get in, view the data by right-clicking on the table, choosing Open Table, and actually editing the data as well. And that way is through what's called the Dedicated Administrator Connection, the DAC. And we do cover this in another video, but again, in those special circumstances where you may need to get in and view the data and edit the data in the system tables, you have to use the Dedicated Administrator Connection. And how you can do it here is you actually have to, you can put the word admin : so you can connect graphically. The preferred way is through the SQL command utility to connect through the Dedicated Administrator Connection. But you can do it here, but just by doing an admin : and you, of course, you have to have administrative rights on the box in order to do this. But that's how you can connect as the Dedicated Administrator Connection, and again, do all of those system things graphically. Alright, so in the CBT Nugget, we took a big look at designing and creating tables. We started off with an introduction to tables, types, and data integrity. I got you familiar with all three of those things. We took a very, very basic look at what a table is, what it consists of, what data types are, the different forms of data integrity and constraints. We then took a look at how to create tables. We created a couple of tables there, both graphically and through Transact SQL. We created a few types there. We worked with some constraints. We created our constraints. We looked at defaults, check constraints, brief look at rules there, how to create database diagrams, and then we took a look at how all that stuff works by entering the data into the tables, taking a look at how referential integrity constraints work, and by setting up our relationships. And then at the end here, we took a look at special tables. We took a look at local and global temporary tables, and then briefly there, how to access system tables. I hope this has been informative for you, and I thank you for viewing.